Right, long division. A forgotten skill, much neglected. Source of confusion to children and adults alike. But I'm not going to start with long division. All divisions are just divisions anyway. I'll start with a reminder of the way that short division works. But again, I'm not going to start with 2 into 5 or 2 into 6. I'll leap straight in with fairly substantial numbers. There you go. There's a scary one there. Not really. Now that's not a long division. Doesn't matter how long that number is. It's this number that qualifies whether it's long or short. It's a short division if I'm quite happy with the multiplication table. I know my 5 times table. I've learnt it by heart. I know how many times it'll go into various numbers. That's what makes it a short division. I don't need to spend time going over, working out how many times it goes in, and then seeing what's left over, writing it all out by hand. But before that, a reminder of the actual process of division, which simply means how many times can I take 5 away from that? I could do it this way. I could start subtracting 5 at a time. Just get into that pile and start shoveling out those 5s. Get 5 out of it. 4860. There's 5 gone. Get another 5 out of it. 4855. Get another 5 out of it. Ooh, 4850. Not too promising. That's going to take a bit of time. Better than that would be, instead of taking these 5s out one at a time, you could take them out in bundles of 10, or bundles of 100, or bundles of 1,000 at a time. Well, I haven't got 5,000. You could take them out 500 at a time. That'd be better. Right, here we go. 4865 divided by 5, taking them out 500 at a time. Whoa, look at that. 4365. That was a big dot going. Take away another 500. 3865. Take away another 500. 3365. That's still taking a pretty long amount of time. It's 100 times faster than that, and it's still no use. Better still would be this, I suppose. Instead of taking away your 500s one at a time, why not just say how many 500s can I get out in one go? So I've looked at that just at the hundreds. I would say that there's 48 hundreds. I want to take away 500s, so that's just like 5 into 48. And I know that's 9. So if I take 900 5s out in one go, there we are. Almost all gone. And then if I take away my 50s at a time, I can't take any 500s anymore, then instead of taking them away one at a time, with just a slightly smaller shovel there trying to get them out, I could say, let's get them all out in one go. Because I could get 7 of them out, that would be another 75s going. That would take me down to 15. And then finally, in we go. Easy peasy, I've won. I've got 973 5s altogether. That division comes to 973. But you wouldn't do that. That would just be mad. No, that's the principle behind it. All you would do to divide by 5, no matter how long this number was, would just be to go through that same process a shorter way. You would just say, same again. Start with the hundreds. Take this in most of the 5s I can take. I can't take thousands out. Start with the hundreds. So the hundreds would be here. So I would say, well, how many 500s can I take out of 4800? That's like 5 out of 48. Well, I know that's 9. I could always put in the working. That's 4,500 gone straight away. You know, the same as the previous one, leaving me 365. And I could say, right, now down to the 10s. So, how many 50s can I take out of 360? How many 510s can I take out of 3060? Well, that'd be 7. So that's 7 for the 10s column. That's 350 gone. Finally 15 left, I know that's 3. Finished. Well, that's certainly a bit quicker than writing down those subtractions, but you still wouldn't want to do that. Because it's a short division. I know the multiplication table. If I was doing 5 into 4865, and I understood that process of I try and get the 500s out, then the 50s out, then the 5s out, I just start with the hundreds. And I know that that goes 9 times. And I know 9 5s are 45. And I can do 45 away from 48. That's only 3. So I don't need to put all that working down. and then 5 into 36. I know that 5 into 36 goes 7 to make 35, so there's only 1 left over. And then finally 5 into 15 goes 3. That's a short division. It's a short division because I know my multiplication table for the dividing number. Right, so something like 9 into 3, 9, 2, 4. Well, that's not a long division. It doesn't matter how long that is. I know my 9 times table. I know that 9 into 39 goes 4, because that's 36. And then there's 3 over. I know that 9 into 32 goes 7. It goes 3, because that's 27. And 27 away leaves 5. And I know that that goes 6. So I get my answer 4, 3, 6 straight away. Short division. I know my multiplication table. I don't need to work it out. I don't need to subtract it. And that's the difference with long division. Long division is exactly the same process. The only difference is I don't know that multiplication table. So if I had something like this, 4617 divided by 19, then I don't know my 19 times table. Or not very far. I could guess it for a little while. And I'm not going to write them all down the side here. I'll just do it as I go along. Exact same process. I could try subtracting 19s until it stopped. If I had a load of time, I could start subtracting 190s or 1900s. But I don't need to. I'll set it out exactly the same way as I did with the other division, with the short division. The only difference is I'm not quite sure. So I'll have to be careful when I start working this out. I'll have to say, right, 19, but there's that clue here. 19's almost 20. I'm going to do my hundreds first. I'm not going to take away 19s or 190s. I'll take away my 1900s. So that's like, how many 1900s from 4600s? Same as 19 into 46. Well, that's almost 20. That's just over 40. It's probably 2. But instead of doing it all in my head, I'll actually write it down. So 2 times that is going to come to 38. I'm not bothering the other figures down, I'll get them afterwards. 38, which leaves me with 8 left over. Instead of putting the 8 up for the 117, I'll bring the 81 down. Now I'll do my tens. How many 19 tens go into 81 tens? My answer for the tens column. Well, it's the same. That's almost 20. That's 81. Should be 4. But I'll need to work it out because I don't know it properly. 4 nines 36. 3 over 76. Again, I need the space here so I can do my subtraction. So that subtraction is going to leave me with 5 left over. Now I've got the units. How many 19s make 57? Almost 20, almost 60, probably 3. I can check it by multiplying it out. 27 carry 2, 57. Exactly. 19 goes into 4,670, exactly 243 times. Same principle. 19's quite easy though. If it was something like, for instance, 4641 divided by 13, not quite so straightforward. Exactly the same setting though. How many 13s are there? Well, I'm not going to start here and start taking away the 13s, or start here and take away the 130s. I'll start here with taking away the 1300s with 13 10s. I'm going to start at the 10s, and it's just a guess to begin with, because I don't know my 13 times table. If you knew a 13 times table, you could just rattle through that. If you're not sure, you'd have to try and figure it out. It's not so good. It's better when they're close to 10s. 13, you think 13 into 46. Can't be that many. It's roughly 12. It could be 3, it could be 4. I'll try the 3, but I'll multiply it out and find out. 3 3s are 9, 3 1s are 3. Remember, I'm just dealing with the hundreds. And as long as that number is smaller than the number I'm going into, it's definitely going in. And as long as there's not too much left over, I can't have 13 left over or more, or it would go again. Then I do my subtraction, there's 7 left over, perfect. Put it on to the next bit, I've got 741 still to pull 13s off of, but I'll do it in my tens now. So, 13, many 13 tens are there in 74 tens? Well, that's the same as 13 into 74. So again, it's a bit of a guess. You think, oh, what's that? Well, 12 into 72. If you know your 12 times here, it's about 6. It could be 5, it could be 6. Well, what you would do is you would try 6, for instance. 6 3s, that's 18, 1 over. That comes to 78. That was wrong. and that happens in long division. So what I'll do instead is, that was too many, so it must be the 5. It happens. So I've got 15, 65, and that's going to leave me with a 9 left over. Now bring the 1 down. 13 into that, well it's certainly more than 5, and it was more than 6 because it was just that one. Try the 7, again it's just sort of guessing, but you multiply it out to check. 21 carry 2, 91, bang on. Answer to that, 357 exactly. Of course they don't always come out exactly. You might have something like this. 10,000 divided by 23. Now that's not going to work. But exactly the same principle. Dividing by 23. I'm not going to take out 23s or 230s. I'm going to go up to the 2,300s, go up to the hundreds. How many hundreds of 23 can I take out? So I start from here. Well, 23 actually isn't that bad. It's almost 25. That's an easy table because it only goes 25, 50, 75, 100. There's 4 in every 100. So that's probably 4. Multiply and check out. 12, carry 1, 9. Perfect. There's only 8 left over. Go down to the tens column now. How many tens of 23 can I take out? Well, 25. That's probably about 3, isn't it? 3 times that, 9, 69. Ooh, it looks dangerously close. Nah, doesn't look dangerously close at all. 11 left over. 23 into that, again there's probably 4 into 100, but that's a bit bigger than 100 and that's a bit less than 25. Could be 5, could be 4, could be 5, try the 4, and that's 12, carry 1, 92, 18 left over. And that's me finished, so I'll just have to say remainder 18, if you're happy with 18 floating about. Or, if you want the answer exactly, I'd put 434, and the 18 has still to be divided by the 10,000. So that would be the exact answer. Cancel that down a bit. Or one last one, if you've not already switched off. Or maybe you're racing off to try some for yourself. Well, before you rush off, one last one. What about this? 211,751 divided by 37. If you can do that, you can do anything. So we'll just go through this same principle. How many 37s are there in that number? How many 37s in 211,000? Loads of them. How are you going to find it? No, you're not using a calculator. You can do it yourself. Will I keep subtracting 37s? No, that'd be stupid. Will I take away 3 70s? No, start at the top. Get the biggest amounts out that you can first of all. Let's go right up. What fact? It's not fact, it's up to the thousands. How many 37,000s can I get from 211,000s? So that means I'm stopping here just now. So I'll just take these first few numbers. 37, not too bad, it's almost 40. 211, 200. I'm going to get a fairly decent guess there. 40 into 200, that's like 4 into 20, that's about 5. If I'm wrong, well, I'll be able to correct it. Shouldn't be too far out. 5 7s, 35, 3 over, 15, 18. So that means I've got 5 from, again, I'm not doing this, that's 6, 26 left over. Oh, that's fair enough. Now I'll go to the hundreds. 276 hundreds still left to dig out these 37s from. So how many 37 hundreds from 267 hundreds? Certainly more than 5, because that was 5. You could think, well, another 80 odd, another 80, another 2 of them, possibly 7. Try 6, try 7, try 8. I'm guessing on 7. That's 49, so there's 4 left over. 21, 25, we'll look at that pretty close. Because in this case then, there's only going to be, what, 8 left over. That was pretty good. I've got 851 left to go. How many 37s can I still get from my 851? Well, going to the tens now. How many 37 tens from 85? Not a lot. 80, 40, 80, it looks like 2, doesn't it? So 2 times that's going to be 74. Well, that leaves me 11. Bring the 1 down. Down to the units. How many 37s from 111? Not a lot. 48, probably 3. And 3 times it. I've not got room to put my extra 3 down here. 3 times 37 is 111, so that was it exactly. The answer to that was 5,723. Now if you can do that, and just try that again yourself, then you can do long division. Just practice it. See you later.